Good morning, my dear students. My name is Twayna, BSc, and I am currently available at the Hamlet Tuition Center, Brahmatal, Kathmandu, and the Kumudini Kunja Secondary School, Kalimati, Kathmandu. My dear students of grade 8, this is your science class, and in our science class, we have been studying about the lesson sound. In our previous classes, we discussed about what is sound and what are the nature of sound, like what are the features of sound wave. Okay, we discussed about wavelength, frequency, wave velocity, and we also learned to do some numericals. We also practiced some numericals. Yes. Okay, today we are going to study a bit about reflection of sound. You know what is reflection, right? Reflection means to bounce back. Reflection means to bounce back. It is same like you throw a ball toward a wall. What happens? What happens if you throw a ball toward the wall? What happens when the ball hits the wall? Will it just simply attach to the wall? No. Will it simply drop? No. What happens? It will bounce back. Yes, it will bounce back. That is reflection. Okay, that is reflection. Now in case of sound wave, the same thing happens. When a certain sound wave hits the wall, then it bounces back, and that bouncing is known as reflection of sound. Say this is incoming sound and this is reflected sound. Reflected sound is indicated by blue colored wave. Incoming sound is indicated by pink colored wave. Okay, and however, some amount of sound energy is actually absorbed by the surface. Okay, if the surface is soft, then most amount of sound energy is absorbed by the surface. Okay, please note this point because it is going to be important for you in our later section. Well, if the surface is soft, then sound is absorbed by it. Okay, because sound is just a vibration, isn't it? So due to that vibration, it easily vibrates and all the energy is absorbed by itself. It will neither transmit that energy to other direction nor reflect that sound. Okay, however, if the surface is very hard, then what happens? It will not vibrate that easily. If the surface is very hard, this surface will not vibrate that easily. As a result, the vibration of air molecules will trigger vibration of another air molecule. Understand? Okay, so only hard surfaces allow the sound to reflect. Only hard surfaces cause reflection of sound, but soft surfaces absorb sound. Okay, soft surfaces absorb sound, and in some cases when this surface vibrates, it triggers. When the surface vibrates and absorbs sound, it triggers vibration of air molecule on the other side as well. Okay, when this surface vibrates, it triggers the vibration of molecules on the other side as well. Okay, that way the sound passes through the wall. The sound passes through the wall. Now if you want to make a soundproof room, okay, like a studio, recording studio, if you like to make a room from which sound will not go out, in that case what you have to do is you need to combine two types of material, one of which absorb the sound and another of which does not let the sound to be transmitted to other side. And how will you perform that? The wall be very hard surface, and on the surface of wall you attach some soft materials. Okay, soft materials such as sponge or soft wood or rubber pad, etc., are sticked to the wall, okay, so that the soft materials, they absorb the sound and the sound is transmitted to this wall, okay. But since the soft materials, they have already absorbed the vibration, the molecules of wall will not vibrate, okay, it will not vibrate, okay. As a result, the air molecule on the other side also cannot vibrate, okay. That way sound will not be transmitted outside. However, if you use only soft material, if you only use soft material, then of course because of sound the soft material vibrates, okay. Soft material absorbs sound energy, means it vibrates, okay. And when it vibrates, it also sets the air molecule behind it into vibration. It causes air behind it into vibration, okay. In that way sound is transmitted to other side. So behind the soft material you keep something hard that will not vibrate, that will not set into vibration due to the vibration of soft material, okay. So if you want to make your rooms soundproof, then you have to combine these two materials, yes, one hard material and on the outer surface of it soft material. That is the combination, okay. Okay, look at the note. You don't need to write that much, that was just for your information. When sound strikes a non-absorbing surface, you understand this? Non-absorbing surface, you must include this point here, because if sound strikes on absorbing surface, then it will not undergo reflection, it will be absorbed, okay. That's why what you need to write, when sound strikes a non-absorbing surface, it returns back to same medium. This phenomenon is called reflection of sound. As light, it also follows laws of reflection. It follows all the laws, or both the laws of reflection, yes. And what are the laws of reflection? The incident ray, or in this case incident sound, normal at the point of incidence, and reflected ray or reflected sound lie in the same plane. That was your first law of reflection. And second law of reflection is angle of incidence is equals to angle of reflection, and that is obeyed by sound as well, okay. Any confusion in reflection of sound? Okay, next part, effect of reflection of sound. Because of reflection of sound, we observe two phenomena. These are echo and reverberation, okay. Echo and reverberation. This is not echo, this is not echo, okay, this is echo, okay. Now what happens is, when sound waves are produced by a source, that wave travels, yes. In this case, okay, let's take an example of echo first. Look at this picture, okay. This is a hard surface, yes. This is the source of sound, and this is the listener's ear, okay. From the source of sound, sound waves are being produced, okay, and that wave is actually produced in all direction, yes. Sound wave is produced and propagated in all direction, okay. And one of the wave is directly transmitted to ear, okay. One of the wave is directly transmitted to ear. Let's say this is direct sound, okay. Let's say it is direct sound, isn't it? And another wave, you can see here, this second wave of sound is actually propagated in some other direction toward the wall, yes. So it has to travel toward the wall, it has to travel up to wall, okay. When it hits the wall, when it hits the surface, then it reflects, okay. It reflects and another wave is created, and that reflected sound also ultimately reaches to ear. So this sound is reflected sound, isn't it? Okay, we have talked here two kind of sounds, okay. One is direct sound and another is next is reflected sound. So actually if you are in a room without any sound absorbing material, then you are actually hearing multiple sounds. One is direct sound, another is reflected sound. You would hear multiple sound. Okay. Now suppose that the wall is situated quite far from the source. From the source to your ear, the sound wave, it comes within 0.03 second. Okay, it takes 0.03 second for the sound to reach your ear from the source. Okay, and here from source to wall, it takes 0.035 second time, isn't it? It takes 0.035 second time, and for that sound takes another 0.025 second time for reflecting. Now see the calculation. For the sound to reach from speaker to ear to listener, it takes 0.03 second time. Okay, another sound which is traveling toward wall, it takes 0.035 second time to reach up to the wall. Yes, and that sound reflects, isn't it? And for the sound to reflect and reach the ear, it takes 0.025 second. Now tell me, in what time will the reflected sound reaches the listener's ear? You need to add it, and it will give you 0.06 second. 0.06 second. See, there are significant time gap between original or direct sound and reflected sound. There is significant time gap between direct sound and reflected sound. In such case, the reflected sound is heard as a separate sound. Okay, like if I say hello, and you will hear like the direct sound hello, and reflected side hello. If I say hello, you will hear like hello, hello, hello. Okay, that is echo, in which the reflected sound is heard as distinguished as a separate sound, individual sound. Understood or not? So you can say echo is a repetition of sound. Okay, now let's conduct the same let's do the same evaluation in this case also, in which wall is very close to the source of sound. Okay, in this case, let's say from the source of sound to ear, once again it takes 0.03 second time. Okay, and from the source to wall, it takes 0.015 second time, and the reflected sound, it takes 0.02 second time. Okay, so in overall, how long does the reflected sound take to reach the ear? How long does the reflected sound take to reach the ear? Have you done the calculation? Okay, it takes 0.035 second. See, are you getting it or not? Are you getting it or not? Direct sound, how long will it take? Direct sound, how long will it take? 0.03 second. Okay, and reflected sound, how long will it take? 0.035 second. Now there is not much difference in time. Yes, in 0.03 second you hear direct sound, and short while, little bit while, in 0.035 second you hear the reflected sound, and this much small gap of time cannot be distinguished by our ear. Okay, this small gap of time cannot be distinguished by our ear. As a result, the reflected sound is not perceived as a separate sound, but it will get mixed up with direct sound. As a result, you will hear the original sound little bit prolonged. Okay, like you can do an experiment. Whenever your classroom is empty, in your classroom there are no sound absorbing objects. Yes, Your classroom might have desks and benches, but these are made up of woods, and woods they absorb some amount of sound, but they absorb smaller amount of sound than clothes. Okay, clothes and curtain. Okay, that's why you can perform an experiment in your classroom. When there is no one in your classroom, you can try to talk or speak in your classroom. What will you hear? You will hear your voice little bit louder. Yes, that is reverberation. That is because of mixing of reflected sound with the direct sound. That is because of mixing of reflected sound with the direct sound. Because of that mixing up, direct sound is heard for a little bit longer time. You can say the difference is 0.005 second. Yes, so your sound will be prolonged by that much time. Your sound will be prolonged by 0.005 second. Understood? Okay, so you understand what are echo and reverberation. Yes, echo and reverberation. Echo means repetition of sound. Reverberation means prolongation of sound. Okay, echo means repetition of sound. Reverberation means prolongation of sound. Okay, what causes them? They are caused by reflection of sound. Yes, now let's take note. Echo is the repetition of sound due to reflection of sound. And in this example we said that echo occurs only when the reflector is far from source of sound. Okay, but if the reflector is closer to the source of sound, nearer to the source of sound, then it does not cause echo, but it causes reverberation. Okay, so it is estimated that for echo to occur, the source of sound and reflector must be more than 17 meter far from each other. Okay, if the reflector is more than 17 meter far from the source of sound, then it causes echo. Okay, then you can hear echo. Now if the boy moves closer to wall, then you will not hear echo, but you will hear a reverberation. Okay, however, I'm assuming that there is a sound absorber in his back. I'm assuming that. Okay, now what conditions are necessary for echo to occur? Definitely, as we have studied here, the source of sound must be more than 17 meter far from reflector. Okay, the distance between reflector and source of sound must be more than 17 meter. And definitely sound must be loud enough, because the sound has to travel a very long distance, isn't it? Yes, and as sound travels farther and farther, its intensity keeps on decreasing. So if your sound is not loud enough, before it reaches the wall or before it reflects back, it vanishes. The intensity of sound or energy of sound becomes zero, and you will not hear an echo. Okay, can you hear an echo of whispering sound? No. If it's just whisper in an empty room, neither you will hear echo nor you will hear reverberation, because whispering has less intensity, which will be diminished to zero before it even reaches to the wall. Okay, that's why sound must be loud enough. And next one, there should not be any material that absorbs sound. Definitely, if there are any material that absorbs sound, then sound will be absorbed and will not be reflected. Okay, and next one, this is very important point. The time duration between original sound and reflected sound must be more than 0.1 second. Here you see what is the difference between reflected sound, so original sound and reflected sound, and here what is the difference between them? The difference is very significant, isn't it? So if time duration between two sound is less than 0.1 second, then we cannot distinguish these two sound as separate sound. Our brain cannot separate or cannot distinguish between the two sound which are which within less than 0.1 second. Okay, 0.1 second भन्दा थोरै टाइममा आइपुगेको अर्को साउन्डलाई हाम्रो ब्रेनले सेपरेट साउन्डको रूपमा डिटेक्ट गर्न सक्दैन. That is because our hearing is not very sensitive. Okay, our hearing is not very sensitive. That's why the sound which comes within 0.1 second cannot be distinguished as separate sound. Okay, so for echo to be heard, the time duration between reflected sound and original sound must be more than 0.1 second. However, in my example that is not the case. Yes, I need to remove 10 from here. Okay, I need to correct it. Okay, I'm sorry for the mistake. Now it's okay. Okay, here the time duration between direct sound and reflected sound is 0.3 second. Yes, but here the time duration between direct sound and reflected sound is 0.05 second, less than 0.1 second. Okay, so in this case you will not hear echo. In this case you will hear echo. Okay, that is all about echo. Any confusion? Okay, the next one is reverberation. As you already know, reverberation means prolongation. Okay, see the red word, prolongation of sound due to reflection of sound. In case of echo it was repetition of sound. In case of reverberation it is prolongation of sound due to reflection of sound. Okay, now what should be the distance between source of sound and reflector for reverberation to occur? It must be less than 17 meter. Yes, the reflecting surface must be closer to the source of sound for reverberation to occur. Okay, now the conditions necessary for reverberation are: sound must be loud enough, that is the first condition, as it is for echo. Okay, second one, the reflector must be less than 17 meter far from source of sound. Third one, there should not be any material that absorbs sound. This is also same as in echo. And the time duration between original sound and reflected sound must be less than 0.1 second. See the time frame, must be less than 0.1 second, and it must be more than 0.1 second. They are just opposite to each other. Okay, now so this is a speaker from which sound is being produced. Okay, and one of the sound wave hits directly to your ear, that is direct sound, and other sound waves, they are reflected by various parts of your room. Okay, various walls of your room, and all these reflected sounds also reach your ear. So these reflected sounds, they get mixed up with direct sound. So if you speak with same amount of energy in the ground, and if you speak with same amount of energy in the room, then there is definitely difference in loudness of your sound. Okay, in room it is heard louder, in ground it is heard dimmer. Got it? Okay, now if you have understood both echo and reverberation, then I hope you can differentiate between echo and reverberation. See, the first point, echo is repetition of sound due to reflection, whereas reverberation is prolongation of sound due to reflection. Okay, and the duration between reflected sound and direct sound should be more than 0.1 second in case of echo, and in case of reverberation less than 0.1 second. And distance between source of sound and reflector surface must be more than 17 meter in echo and less than 17 meter in reverberation. And echo, it occurs in large hall, near hills, etc., whereas reverberation occurs in small rooms, especially non-furnished. Okay, any confusion out here? Okay, now the last note here, if you have gone to auditorium hall or cinema hall, you notice that the walls are carved, the walls are covered with soft wood, the walls are covered with soft wood, okay, or sponge or carpet. Okay, these materials I have already told you in the beginning of today's class. These materials help to absorb the sound and prevent echo or reverberation. Okay, so echo and reverberation, they will actually disturb the original sound. Now think about a hall. Okay, a hall or auditorium is very large, isn't it? Yes, so the reflected sound might arrive after 0.5 second, 0.6 second, or even after 1 second or 2 seconds. The reflected sound might come to you after very long time because of very large size of a hall, if there are no sound absorbing material. Now think of the situation in which this scene has already gone. You have already heard the dialogue, but the same dialogue is repeated 2 seconds after, which obviously would disturb the present dialogue, isn't it? That is why echo and reverberation are not desirable in such places. Okay, repeated sound may interfere original sound. That is why soft materials are used to cover up the walls of hall and auditorium, which absorb sound energy. Understood? Any confusion? Okay, if there are no confusion, then we have to do a small numerical, short numerical. Okay, let me pause the video to copy question. Okay, I've copied the question. Hari shouts in front of a cliff. The distance between the cliff and Hari is 150 meter. If the speed of sound in air is 332 meter per second, calculate the time to hear the echo. Okay, while performing any numerical, what you have to do first, you need to take out the given information. Yes, here distance between Hari and cliff, that means D, is given 150 meter. Okay, then speed of sound is given in air, that means V is given 332 meter per second. Now you need to find out time taken for echo to hear. Okay, that means T equals to what? Okay, now as we know, okay, which formula we might have to use? If speed is given, we definitely have to use the formula of speed, because distance is a fundamental quantity and time is also a fundamental quantity. However, speed is a derived quantity which depends on distance and time. So as we know, speed is equals to distance traveled divided by time, isn't it? Distance traveled divided by time. Now I'd like to write it in fraction form. Yes, okay, let me write it like this. S, okay, D we have indicated by ds, D by T. Okay, here is my fraction. Okay, I feel little bit uncomfortable with D because D is used for density. Yes, okay, let me replace it by S. Okay, now you can see V equals to S by T, velocity or speed equals to distance traveled by time taken. But here we have small problem. Okay, the problem is, suppose the boy is standing here. Okay, boy is standing here and the cliff is here. Yes, then the sound produced by boy, it has to travel this much distance, isn't it? Is it or not? Yes, the sound produced by boy has to travel this much distance. That means the distance between the boy and the cliff. But when sound reaches here, will the boy hear the echo? No. For echo to be heard, this sound must return to the boy, covering the same distance once again. Okay, covering the same distance once again. So what I meant is, for echo to be heard, sound has to travel twice the distance. Understood? Because for echo to be heard, sound has to travel from boy to the wall and then again from wall to the boy. See, the sound has to travel 2 times. That's why the distance covered would be 2 times S. Okay, the distance traveled would be 2 times of S. Any confusion? Okay, now let's put whatever value we have. V 332 meter per second equals to okay, I just copied the fraction, okay, because you know it how hard it is to keep the fraction. Okay, now 2 times, what is the value of S? 150 meter. Okay, माथि ठाउँ पुगेन, तल आयो यो number. Okay, बल्ल बल्ल ठाउँ पुग्यो. ल ठीक छ, अलिकति ठुलो बनाइदिए. Okay, यति भयो है. Now you need to find out the value of t. How would you do that? By isolating t. And how can you isolate t? By cross multiplying, isn't it? By cross multiplying, you can isolate t like this. If you cross multiply it, it will be 332 into t. Yes, 332 into t. Okay, 332 meter per second. Yes, equals to in left side what you have, 2 times 150 is 300 meter. Okay, see, 2 times 150 means 300. Okay, minute. Now I told you you need to isolate t, isn't it? So t is accompanied by this number, so you need to move this number to another side. Okay, and that you can do by once again cross multiplying. T is equals to, you get 300 meter. Okay, once again I need the fraction. Okay, I'll take the fraction. This one I'll take because this one is longer. Okay, in numerator you have 300 meter, and in denominator by cross multiplying you get 332 meter per second. Okay, so if you divide it, how much will you get? Let's see, calculator. Okay, 300 divided by 332, 0.9. Okay, 0.9. And meter divided by meter per second, the denominator of denominator goes to numerator, meter cancels, you can simply write second. Or you do not need to calculate for units. You know that SI unit of time is second, so you can directly give the unit. Okay, now you can give the conclusion. Therefore, Hari hears the echo after 0.9 seconds. Okay, this much. Any confusion? Okay, no confusion. Yes. Okay, that's all for today. Okay, your lesson is completed. Now you need to find out some of the applications of echo. That means, what are the uses of echo? Why echo is useful? That is your homework, your assignment. You search it, you find the answer. I'm not going to give you the answer. Okay, now what you have to do, you know that since the lesson is completed, you have to do the exercise from your book. Okay, from the textbook you have. You can use any publication textbook. Yes. Okay, then take the picture of the exercise you have done. Okay, not the questions but the solutions from your copy. Okay, take the pictures, send them to me via messenger. Okay, I'll check it there. Okay, and give you feedback. Okay, thank you class.